Alright, in this video, I'm going to show you how to create a piecewise function when you're given the graph of a piecewise function. And you might notice that specifically number 7 is an absolute value function, but we can treat it like any other piecewise function as we create the equation for it. Let's colorize this a little bit. I'm going to look at this left side as the blue side, and I'm going to look at the right side as the red. Okay, so we're going to need an equation for the blue side and an equation for the red side. So look at this blue side as a line as opposed to just a segment. So think y equals mx plus b as we do this. Y equals mx plus b. So if I want an equation for this, then I need the slope m. Now I notice this is going downhill, so I know it's going to be negative something. Now I'm going to pick a couple points to see where it's hitting right at the grid lines. And as I travel from left to right, it looks like I'm going down 1, right 2, down 1, right 2. So that's negative 1 over 2. So that's going to be my slope is negative 1/2. Okay, so so far I have negative 1/2 x. Now we need the y-intercept, b. Well, the y-intercept is actually right here, all right? This line crosses the y-axis right at 0. So I'm not actually going to write anything for that. All right, so there's the equation of the blue line. So now I need an equation for the red line. So again, I'm thinking y equals mx plus b. So I need the slope. So, okay, I see the vertex here, and so I can see that this line is going up 1, right 2, up 1, right 2. So that's going to be positive 1/2 x for this. Now, what about the y-intercept? Now, this red segment doesn't reach all the way to the y-axis, but we're interested in the line that contains this. So we can just extend this and see where it would hit if we kept going. So if we kept it to the left, this is going down 1, left 2. So if I kept going down 1, left 2, kabam! You can see that it would hit the y-axis at negative 4. So that makes this y equals 1/2 x minus 4. So now we have an equation for the blue line and an equation for the red line. So as we make our piecewise function, it's going to look like this. So we have f of x equals, and we'll make a brace big enough to hold 2 equations. So for the blue side, we have our negative 1/2 x. And for the red side, we have the positive 1/2 x minus 4. Now we need the domain restrictions that will stick on the end here to limit the line, which really goes forever, but we want to limit it to just the left side. And even though there were no arrows, I know this goes on. So notice the axis of symmetry. Okay, this is the x value where the graph changes from the blue piece to the red piece. So the x value is positive 4. So that's what we're going to use for our domain restriction. So it's going to be this blue equation if the x values, and we're going to say something about this number 4. Now, the blue side is going to the left. So these x values are less than 4 because they're to the left of 4. So we're going to say less than 4. Now for the red side, these values are going to the right. So these x values are greater than 4. So we'll say if x is greater than 4. Now if we left it like this, both of these would be open circles here, and this vertex would be an open circle. You don't want that. So one of these needs to be or equal to. And I usually just let the first one be or equal to, but it doesn't matter which one of these you put or equal to. And that's it. So we've created a piecewise function for this graph. We're also supposed to say the domain and range, so let's go ahead and take care of that. This graph goes left forever and right forever, so that's negative infinity to positive infinity. Now the range is the y values. How far does it go from bottom to top in that order? Now the lowest value is here at -2, a y value of -2. So bracket -2, the -2 is included, and it goes up forever. So -2 to infinity, bottom to top, the order matters. Okay, let's go ahead and do one more of these. Let's see how we would graph this piecewise function for problem number 8. So again, we're going to need an equation for this left piece and an equation for the right piece. Now to help you follow what I'm doing, I'm going to color the left piece blue, and I'll leave the right piece to be red. So I need an equation for the blue. And again, in my mind, I'm thinking y equals mx plus b. So I need the slope of this. If I put a few dots on here, right where it's hitting the grid lines, I notice that from left to right, it's going up 1, right 1, up 1, right 1. So that's a slope of 1. So I'm just going to put x. But now I need the y-intercept. Now this blue ray does not come in contact with the y-axis. But if I look at the line that contains this ray, I could extend this and see where that line would hit the y-axis. So starting from here, if I kept going up 1, right 1, kabam! I can see that that would hit the y-axis right here at 9. So that makes this y equals x plus 9. Now looking at the red part of the graph here to the right, okay, again thinking y equals mx plus b, what's the slope here? Now going to the right, rise over run, it's going down 1, right 2, down 1, right 2. So because it's going downhill, you know it's going to be a negative slope. So that is -1/2, down 1, right 2, -1, right 2. So that's -1/2 x. And then the y-intercept is right here. The y-intercept is 0 where it crosses the y-axis. So I'm not going to put anything there for the b value. So now I'm ready to write my piecewise function. Okay, so I'll have f of x equals, and I make a nice brace, like this. So here comes the blue function. So there's my x plus 9. And then my red function is my -1/2 x. So now it's time to put on my domain restrictions that will keep it from being this entire line, and instead just the left side. Now there's no, we don't call it the axis of symmetry. This graph doesn't have a mirror image on the left and right. However, let's consider the x value where it changes, where everything changes from the blue piece to the red. Can you see the x value where it changes from blue to red? Well, see this gap right here, this jump? Can you see that this jump is happening at -2? So that is the value that we're going to mention in our domain restrictions, similar to the way I use the axis of symmetry. So it's going to be the blue piece to the left of -2. In other words, if the x values are less than -2. This is an open circle, so I have no choice but to leave this less than -2. We are not to include the -2. As we can see, it's an open circle. Now for the other piece, we want, it's going to be the red function for x values that are greater than or equal to -2. That's a closed circle, so we're including -2 in this piece of the function. And it's going to the right, so that's why I put the greater than or equal to. And that's it. So that's how you make an equation when you're given the graph of a piecewise function. Now the domain and range. So this graph goes to the left forever and to the right forever, and no x values are missed. So that's just going to be -infinity to +infinity. Now the range is the y values represented on this graph. So in other words, how low does it go and how high does it go? Well, this graph goes down forever, so I'm going to start with -infinity. That's how low it goes. Now it goes up to a height of 7, so I'm going to mention 7. Now you might be thinking, wait a minute, that's an open circle. It doesn't go to 7. You might be tempted to say 6 to avoid the 7. But you can't do that because you'd be leaving out all these little decimals between 6 and 7 that should be included. So you go ahead and say 7, but you show that the point at 7 is not included by making it a round parenthesis instead of the square bracket that we often do. All right, this means that the 7 itself is not included. And that's it. Okay, so now there's some sort of random questions that are included that pertain to number 7 and 8. So I'm going to go ahead and include these questions in this video. Okay, state the y-intercept. So these questions are all about number 7. So what's the y-intercept? Okay, so the y-intercept of this graph as a whole is the point 0, 0, because the graph touches the y-axis right here. Okay, so that's 0, 0. State the x-intercepts. Okay, this graph touches the x-axis in 2 places, 0, 0 and 8, 0. That was not a very good 8. Let me try that again. Okay, state the axis of symmetry. That was x equals 4. I mentioned that. State the range and domain. All right, I totally already did that. So those were -infinity to infinity and -2 to infinity. Okay, state the absolute value equation. All right, that's new. So we wrote a piecewise function, but this is an absolute value function. You can tell by the fact that it's a symmetric V. So yeah, let's talk about that. So if I want to make an absolute value equation for this, I'm going to want to pay attention to what the vertex is. Clean this up a little bit. Okay, so notice that the vertex is here at, it's to the right 4 and down 2. So whereas the parent function is absolute value of x. If this is to the right 4, then that means I'm going to have x minus 4 inside the absolute value symbols, because this would push you to the right by 4. It's the opposite of what you would normally think. Because it's down 2, that means I need a negative 2 on the end. And then here in the front, I need a number that reflects the slope of the right-hand side. So the right-hand side is going up 1, right 2. So that is 1/2, positive 1/2. And an upward facing v is always going to be a positive number here, by the way. All right, so there it is. So I'm just going to recopy that down below. 1/2 x minus 4 minus 2. Okay, that is going to do it for this video. On the next video, we will see how to evaluate piecewise functions using equations as opposed to using the graphs. All right, see you on the next video.